Okay, geometry fans, our topic for today, this is Notes 8-7, the law of cosines. So after this lesson, students should be able to use the law of cosines to solve triangles. Before we begin, let me give you your joke of the day. Why shouldn't you wear glasses when you play football? And the answer is because it's a contact sport. Contacts, get it? Now, in the last class, we talked about the law of sines. So there's also what we call a law of cosines, and I'm going to show you how we get the formula. The formula is going to look more complicated than the law of sines, but I'm going to show you that it's actually pretty easy to use. So let's say we have a triangle ABC, and we're going to drop down an altitude, a height, which we'll call h. Now, just like the last time, it creates two right triangles, okay? The one on the left and the one on the right. Now, to derive the law of sines, we were using SOHCAHTOA, we were using sine is equal to the opposite over the hypotenuse. So today, we're actually going to use Pythagorean Theorem. Now, in the big triangle, opposite angle A, this is side A. Opposite angle B, this is side B, this whole thing. And opposite angle C, this is side C. Now we don't know the two small pieces here of side B, but if I call this X, this is whatever's left over, which is B minus X. So if we take this triangle, this right triangle here, we can do the Pythagorean theorem, and we can say that x squared plus h squared is equal to a squared. Here's the hypotenuse of this right triangle. So actually I'm going to write it, I'm going to say a squared equals x squared plus h squared. That's the sum of the two legs right there. And then we can also do the same thing for the second triangle on the right, this right triangle. In this one, the hypotenuse is c. So we'll say, I'll write it here, c squared equals, and it's, now this is b minus x. b minus x, that quantity squared, plus h squared. Now we're going to work with this one here. When we square this binomial, so think about if you've learned foiling, if you call it double distributing, when you square a binomial, we multiply it by itself. So b times b is b squared. B times negative x is minus bx. This would be negative x times b, which is also minus bx. And then negative x times negative x is positive x squared. And then I can write that as b squared minus 2bx, because this is minus 1, plus x squared. All right, so now let me come back to this equation here. C squared equals, this is b squared minus 2bx plus x squared, and then plus h squared. Okay, now that looks very complicated, but we also know a squared is equal to x squared plus h squared. Well, here's x squared plus h squared, so I'm going to replace this with a squared. And so what we get is c squared equals, now this is a squared, I'm going to put this in front, plus b squared minus 2 times b times x. Now we're almost done. So one more thing here. X is not part of the big triangle. So we're talking about the big triangle here. We're using Pythagorean theorem, but we want to be using A's and B's and C's. We don't want to use X. All right, now, if I look here, here's where X is. If I look at this triangle, okay, I'll come over here and rewrite this. There's X, there's C, that's angle C, here's A, and here's the height. Now, I don't want to use x, I don't want to use h. Well, if I use the cosine of c, the cosine of angle c, so SOHCAHTOA, cosine is the adjacent, which is x, divided by the hypotenuse, which is a. And then what I can do is I can multiply both sides of the equation by a, And so what we get is A times the cosine of angle C is equal to x. Now I'm going to take this and I'm going to substitute it for x right there. And so what we get, this is the final equation, we get c squared equals a squared plus b squared minus 2. Now that's times b times a times cosine c. I'm going to put the a in front of the b, so 2ab times the cosine of c. This is called the law of cosines. Now again, it looks very complicated, but a, b, and c represent the sides of the triangle, a, b, and c. And if c squared is the one on the left side, when I do this last piece here, it's minus 2 times a times b times the cosine of that angle, of angle c. Now this is how you usually see it in a book. However, if I had started with a squared, it would be b squared plus c squared. It's the sum of the other two sides, sum of their squares, minus 2. It would be b times c times the cosine of angle A. So there's a pattern to this. So c squared, a squared plus b squared, and then I'm using, when I multiply here, it's 2 times a times b times the cosine of this angle. And here, b squared plus c squared minus 2 times b times c times the cosine of this angle. All right, so again, it looks complicated, but once you do it a few times, it's not that bad. So situations where you can use the law of cosines, yesterday we talked about the law of sines would work if it was angle side angle, angle angle side, or side side angle. But we said it does not work if it's side 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 or side angle side. Well, in this case, the law of cosines will work for side side side, because in the formula you have 3 lengths and you have 1 angle. Those are the 4 pieces of the formula. So if I know the 3 sides, then I can find the missing angle. As long as I know 3 of these things, I can always find the 4th. So side 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 works. And the other one is side angle side, which also works. So if I have side angle side, this situation, so what I'm missing is the 3rd side. So I would know this would be the piece I'm missing here. This would be my c squared. This is c. These are my a and b minus 2 times ab times the cosine of this angle. Now one last thing before we do an example here. This should look familiar to you. How about Pythagorean Theorem? A squared plus b squared is equal to c squared. The difference is that we have this situation here. Now Pythagorean Theorem only works for a right triangle, and the c is the hypotenuse in this case. So just to show you, if I type the cosine of 90 degrees, the cosine of 90 is equal to 0. Well, if I were to use this equation, and if this value was 0, 2 times this times this times 0, anything times 0 is 0. So this would wipe out, and what you're left with is c squared equals a squared plus b squared. That's your Pythagorean theorem. So the Pythagorean theorem is actually a special case of the law of cosines. It's when you're using an angle measure that's 90 degrees. Okay, so let's do number 1. Solve the following triangles. So they give us 2 sides, 3 and 4. We're missing side A. They give us 1 angle, 30 degrees. We're missing beta and gamma. Now this is side angle side. The first thing we'd have to find here is the 3rd side, the missing side. So this is going to be, when I set up the equation here, I'm going to use this, okay, if I want to do A, B, C. A squared, this is the side that I'm missing, that's opposite the angle. That's important. Okay, when I do the formula, the angle that I use has to be the angle that's opposite that missing side, or opposite the side that's over here by itself. So I'm going to say a squared equals, Here's b and c. It doesn't matter which one is which. I'll say 3 squared plus 4 squared minus 2 times b times c, which is 3 and 4, times the cosine of the angle measure. Okay, so if I want to label, this is b, this is c. So a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A, 30 degrees. Now I know that looks kind of complicated, but since everything is on the same side, I'm just going to type it exactly how I wrote it. 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 30 degrees. And we get a decimal here. We get 4.22. A squared equals 4.22. Well, to solve for A, we take the square root of both sides. And if we take the square root, now I'm actually going to take the whole answer before I round it. So I'm going to tell my calculator, type the whole thing in, 4.215390309, and give me that answer. So A is equal to 2.05. If you rounded it to 2.1, that would be okay. All right, I'll go to 2.05 here. So we just found the length of A. We still are missing two angles, beta and gamma. Now we have options though. Now that we have all three sides, we could do the law of cosines again to find beta or to find gamma. But we could also do the law of sines. And the law of sines is a little bit easier. So in this case, I'm going to do that. Now here's where I need to be careful because I have a choice. I have enough information to find beta and I have enough information to find gamma. But I am going to find beta first. And the reason is this. Beta is opposite the length 3. Gamma is opposite 4. And 4 is the longest side of the triangle. So remember, in the last lesson, we talked about when you find this will be the biggest angle because it's opposite the biggest side, but there's a potential that this is an obtuse measure, that this is more than 90, and unfortunately, the calculator will not tell me that. So I want to avoid using the law of sines here because I may have an ambiguous case where I have two possible solutions. So I'm going to find beta. Now the law of sines, remember, is the sine of angle A divided by its opposite length equals the sine of angle B divided by its opposite length equals the sine of angle C divided by its opposite length. In this case, I'll use, here's beta. I'm going to find that. So I'll say sine beta divided by its opposite length 3 equals, the other angle I'm going to use is 30 degrees, and I also know its opposite side. So the sine of 30 degrees divided by 2.05. And to remind you, the way we solve it, we cross multiply. So we get, I'll come down here, we get 2.05 times the sine of beta is equal to 3 times the sine of 30 degrees. But then we're going to divide by 2.05. And you can do this in one move. You don't have to show all of this. Now I'm going to type it on the calculator. 3, here I'll type it as a fraction. So 3 times the sine of 30 degrees. Now I'm going to divide that. Again, I could use 2.05, but I want to save my rounding until the end, if I can. So I'm going to divide by that answer, because it's more accurate. And we get 0.73, but that's equal to the sine of beta. I don't want the sine of beta, I want the angle beta. So to do that, I have to take the inverse sine of both sides. So I'm going to have beta equals the inverse sine of 0.73. So inverse sine of my answer, and we get 46.94 degrees. 46.94 degrees. So beta is 46.94 degrees. That's my second answer there. Now, we're not done. We need to find the third angle, which is gamma. Now, you could use the law of cosines, you could use the law of sines, but we want to make life as easy as possible. If we already know two angles, we always know three angles add up to 180 in a triangle. So if I take my answer and I add 30, and then I subtract that from 180, we get 103.06 degrees. So 103.06 degrees. And if you round that to 0.1, if you round this to 0.9, that's fine. Okay? And it's a good thing that we found beta first because this is an obtuse angle. But the calculator, if we had done the law of sines, would not have given that to us. So that's the first example.